So now what we're going to do is we are doing graphs of functions. So we're going to do some key points on graphs. So the first part says state the domain and range using interval notation and answer the questions related to the graph. So for domain, we're going to see how far does our graph go to the left. So if we notice there's an arrow here that shows us that it is slowly going to go to the left. And then we look here, and then if we look right here, we do have an open circle up here that tells us that that's where the graph stops. So for our domain, it goes from negative infinity all the way up to 7, and it is a closed circle at 7. Then we look at the range. How low does our graph go? So it looks like our graph, this is the lowest point, but you do have to notice that this arrow is pointing down. So that means that the graph is going to continue down. Then we go up and we look, how high does our graph go? It goes all the way up to 4. So for the range, it's going to be from negative infinity all the way up to positive 4. Okay. Then we check to see, is this a function? We do that by doing the vertical line test. It definitely passes a vertical line test because it does not cross more than once on any section, on any particular section. So that one is good. Yes. Okay, so there are some other key points that we look at on graphs. So the first one is x-intercepts. So where does our graph cross the x-axis? So here it crosses the x-axis at negative 5. So the x-intercepts are x equals negative 5. It also crosses right here negative 3. So x equals negative 3. Oh, you know what? They want us to write it as a point. I'm sorry. I should have saw that before. So when you write it as a point, it would be negative 5, comma 0, negative 3, comma 0. The next time it crosses the x-axis will be right here at 6, so 6, comma 0. The y-intercept, where does it cross the y-axis? So when we're looking for the y-intercept, it crosses the y-axis here at negative 2. So then our y value is negative 2, so it's 0, negative 2. All right, the next one wants to know, increasing. A function is increasing on an interval if the values of y increase as the value of x increases. The intervals where the function is increasing are, okay, so when we're looking for where it is increasing, we're looking for where the graph is going up. So if we look, it goes up right here, it hits this peak, and then it changes direction and it starts to decrease. So our graph keeps going, going, going. It's like we're on a roller coaster. All of a sudden hits the very bottom, and then it changes direction, and we start increasing again. Okay. So when it asks us, what is the interval where it is increasing, we're giving these values on the x-axis between here and here, our graph is increasing. Now, we do have to take into account that this is an arrow. So that means this is going to keep going in this direction forever. So it will, remember we read our graphs from left to right, it'll be increasing from negative infinity all the way up to this number, which is negative 4. So I'm going to write it here from negative infinity all the way up to negative 4. And then remember, when you have more than one boundary, you put a U. And it's also increasing from here, which is 3, all the way up to here, which is 7. That's where the very last of the graph is. So from 3 to 7. So I'm going to put here from 3 to 7. Okay. Now decreasing. Where is our graph going down? So a function is decreasing on an interval if the value of y decreases as the value of x increases. The intervals where the function is decreasing are, so if we look, the interval where it is decreasing will be from right here to here. This is the only section of our graph that's decreasing. So from negative 4 to 3. So from negative 4 to 3. And that's it. So constant, a constant is a function is a constant on an interval where the value of y is the same constant as the value of x increases. Are there intervals on which the graph is constant? So constant is when it's a horizontal line, so where the graph is just straight across. And in this case, we do not have anything like that. It's just curves going up and down. So this is no constant. Okay, so let's go ahead and try some more examples. Here's another graph. It says analyze the following graph. It says finding roots from the graph. So what are all the real solutions of f of x equals 0? So roots, solutions, all of that means the same thing. X-intercepts is just asking where does the graph cross the x-axis. So I'm going to go ahead and find all of them. There's 1, 2, and 3 points. Okay, so here the first one is -1, 0. The next one is 4, 0. And the next one is 8, 0. Okay, and the next one, the domain and the range. Determine the domain and the range from the graph. So we are going to see what are my x values. So if I look here, my graph continues forever in this direction. I do have a hole right here that I'm going to have to take into account. Then it keeps going. I have a hole here, but if you notice, it's filled in right there. So we don't have to worry about that. And then it keeps going, going, going. And because this arrow is pointing slightly to the right and up, it means it's going to go forever. So pretty much it covers all real numbers except for this hole right here, which is -3. So it's going to be from -infinity to -3. And then u, -3 to infinity. And I use the parentheses because it does not touch at -3. Now for the range, we're going to see how low does our graph go. So if we notice right here, it's going straight across. It's not going to fall under here. Then it goes up. I do notice there's a hole here, but on this side, it is closed. So we don't have to worry about that being empty. The same here, we have a hole right here, but it is filled in with this graph, so we don't have to worry about it, and it keeps going up forever. So we, well, it doesn't keep going down forever. I don't know, I put an arrow. It's going to be from this point, which is -3, and it does touch at -3 all the way up to infinity. So let me go ahead and erase those lines just so it doesn't get super messy. Okay, the next section, it says finding negative and positive domains. So this one is a little bit different than increasing and decreasing. So when you're finding negative and positive domains, it says find all the values of x for which f of x is greater than 0. So all the numbers that are greater than 0 are positive numbers. So this is a fancy way of saying when is your function positive. Okay. So if we look here, our function is positive all up here. Okay, these are your positive y values. So this is where our function is positive. Okay, now we need to give the intervals on which our function is positive. So we have to completely ignore this bottom piece. Let me see. I don't know if this will work, but yeah, I think it's gonna work. So we are ignoring all of this. Okay, do not look at this section here. I'm just gonna leave this part so you guys can see the numbers, but I want you guys to ignore the part of the graph that is under the x-axis. So just look at these numbers. Okay, we just need them for the number line to give intervals. The rest of this we don't need. Okay, so we're just looking at the top part of the graph. So the intervals where it's positive, we have this little section right here. And then it has a hole right here, but it's filled in here, so it goes all the way, and then it doesn't fall under the graph until up to here. So what are those numbers? This number is -1, and this number is 4. So that is our first one, -1, 4. We put a U, and then it doesn't come back up above the graph until this number here, so that number is 8, and it goes up forever, so that means it's going to continue to the right forever as well. So it is from 8 all the way to infinity. Okay. The next section says find all the values of x for which f of x is less than 0. So when it's less than 0, that is a fancy way of saying negative because all the numbers are negative that are less than 0. Okay, so I'm going to go ahead and erase all this craziness that I put. And now we're going to go backwards. So I am going to ignore all of this top part section because this is where all our positive function values are. and we're just going to focus on the bottom part. So this is the section that is under the graph. This is where our function is negative. Okay, so we're going to name the intervals. So it goes from -8, but there is an arrow, so it's going to be from negative infinity. It goes, we do have this little hole here, and then we have all the way up to here, which is -1, and then it does not come back under the graph until right here at 4, and then it stays under up to 8, and then that's it. So I'm going to go ahead and have to give those intervals. So where it's negative is going to be from negative infinity to -3. We have a hole, so we don't see our graph at all there. It starts back up at -3 and ends at -1. This number is -1. And then for the u, it doesn't come back under the graph until 4 all the way to infinity. And then these are brackets, and then this one should be a bracket as well. No hole there. Okay, and that's it for negative and positive domains. Next, find increasing or decreasing domain. So let me go ahead and erase this disaster that I have again. Okay. So we're doing increasing and decreasing. So this part right here is constant, okay? It's not increasing, it's not decreasing, it's just constant. Okay, then our graph is going up, up, from here to here. Okay, then our graph starts to go down, it drops, and then all of a sudden it takes a turning point. So it's going up from here to here, down from here to here, and then it takes a turning point and starts going back up again, which is this section in your domain. So when we're giving these intervals for increasing, it is going to be from -4. We have this little gap here, so we're going to do -4 to 3, -3, and then u from -3 all the way up to 2, and then it starts to decrease. So I'm going to go ahead and put where it's decreasing from 2. It's an open circle at 2, so I'm going to go ahead and use a bracket on this section of the graph, and then it goes all the way up to 7. And then it doesn't decrease again, it starts increasing again after that, which is from 7 all the way to infinity. Okay. Now we do have one more example with another different graph. So here we have analyze the following graph. This graph doesn't have arrows where it shows it goes on forever and ever. It does have a little constant section. So let's go ahead and look at the questions. It says, what are all the real solutions of f of x equals 0? So that means, remember, roots are a fancy way of saying zeros, or f of x equals 0. Those are also called solutions. So these are my x-intercepts. We have one at -9, 0. And it doesn't cross again till about right here, and it doesn't tell us what that number is. So I am going to just give an estimate, 5.9, 0. Okay, visual domain and range. So our domain, it goes from here, which is -9. It covers all these numbers. We have a hole up here, but it's filled in right there, so we're good. It doesn't stop until 7. So from -9 to 7. Brackets on both. The range, we see how low does our graph go. So this is the lowest, from -2 all the way up to 4. Okay, now finding negative and positive domains. So remember, this is where I go ahead and we're looking for when f of x is greater than 0. That's a fancy way of saying when is it positive. Okay, so all the positive function values are above the x-axis. Okay, so I'm going to ignore that section, and we are going to give the intervals where it is above the x-axis. Okay, so from here all the way up to here, it is above the x-axis. So this number is 1, 2, 3, 4, 5, 6, 7, 8, 9. This number is -9, and this number is 1, 2, 3, 4, 5, 6. Oh, that's the one we estimated, right? As 5.9. So it is positive between -9 and 5.9. Okay. Now we're going to give the intervals where it is negative. So I am going to ignore this top part because that's where it's positive. It doesn't become negative until it falls under the x-axis. Okay, and the only section of our graph that is under the x-axis is this little section right here. And that is from when it crosses the x-axis, which we estimated to be at 5.9, and it stops here at 7. So it is going to be from 5.9 to 7. All right. Then the last section says find increasing or decreasing domains. So that means where is our graph increasing and where is it decreasing? Okay. So we follow our graph. It's going up, 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 and then it hits a plateau. It hits a constant. This is constant. It doesn't ask us anything about constant in this section. So we're good. We just need to give these intervals, which is from -9 all the way up to -1. That's where our graph is going up. So from -9 to -1. Then our graph is constant, and then after that, it drops, it teleports, and then it drops down right here. So we need to give this interval from here to here, which is 3 to 7. So here I'm going to put from 3 to 7. And that's it. If you guys have any questions, let me know. Thank you guys. Bye.